Hello, we are doing relative motion in 2D today, and I have my question. A plane is flying due north at 265 km per hour. There is a wind that comes from the east at 55 km per hour. What will be the plane's new velocity with respect to the ground? So V plane originally is 265 km per hour north. That's what is given. Second, I have V wind is 55 again kilometer per hour, and that's east. And what is required will be V plane from the ground. If that's the case, then all what I need to do is to draw my coordinates. So I have the east to the west, north to south, take a scale on my graph, and then start the graphing. First, I have the V plane is 265 km per hour north. So north, I start from here and I go up, okay, with my scale up to the value that I decided on, the 265 basically. That's has to be thicker so you can see it. So that's original V plane, right? And then we have V wind. V wind is going to the east, so I am starting here, and it's just a 55 kilometers. Say it ends here. That's V wind. Basically, I want to get the relative velocity for the plane when somebody from the ground is watching. To add these two vectors, I need to have them both in the same direction. So let's start with the wind. Wind starts here, ends here. Then I will take another vector to represent my plane velocity and end it the same here, which is parallel to what I started before. That will be V plane. So when you add two vectors, you start from the origin, take one vector, then you're gonna take the second one, and the end here, these two ends represent your resultant vector. That's what I'm looking for. Okay, now if I want to do this algebraically, then so this is VP relative, let's call it, right? VP relative, that's what we were looking for. If I do this algebraically, I want the magnitude, so that I can get from Pythagorean theorem. So I have VP relative, which is going to be the hypotenuse for this triangle, will equal VP squared plus VW squared, and then we square root that. Okay, sub n the values that we have, 265 squared plus 55 squared. When we do the calculation, that will lead us to a 270.6473 kilometer per hour. How many significant digits did I start with? Well, I started with 3 significant digits, 2 significant digits. So I'm gonna take the least one, which is 2, so that will be around 270 kilometer per hour. Now for the other part, which is the direction. If I wanted the direction, I can get this angle or that angle. Probably I'm gonna get this one. It's easier for me to get through my triangle. So this angle here, I have the value for VP, that's the 265. I have the value for VW, that's the 55. These represent the opposite and the adjacent for my angle. In this case, that will be tangent of my angle theta equals the 265 divided by 55. So how do I get theta? I will just do a second function, or inverse tan 265 over 55. That will lead us to theta equals 78.27, or more likely so because we're dealing with two significant digits, 78 degrees. So in this case, I will say my V, P relative, which is the final answer, is 270 kilometer per hour and direction. Okay, so that's 78 degrees from where to where? North of east. North of east. That will be it for us today. Thank you for watching. If you like our videos, please subscribe to our channel. Have a great day.